Okay, so here with volume VOP, and remember, first input boop, is our VDB, second input will be our point. Let's just do the actual points from the full thing. So it's going to be this one. Right. So let's go in here. Let's do point cloud open. And where do we want to do the point cloud? Well, we want to do it from the second input, because remember, first input is going to be our voxels. And where do we want to look? Well, we want to look for at the position of every voxel, because every voxel has a position, right? We cannot see that in here, but it's similar to points, so it will just have positions. Right. So in here you can see these things that I mentioned, right? So the radius and the number of points. So radius and how many friends can you find? So it's going to be that. And then this thing is going to ask like, oh, what do we want to find? So at least that has the potential to ask it. Like it's not asking it yet. Basically what the point cloud open will output is the number of the point that we find in the second input. So if we're looking at the second input, and if it finds for a point, it will output the number of that point and any associated maybe values that it has. So after a question that I got on my Houdini 101 course, which was basically someone who didn't understand what volume samples were, and if I wanted to explain a little bit more. So, and then I thought, okay, maybe that's also interesting to include sort of that explanation that I used into this part of the course. For this, I recorded this after I recorded the other parts of the course, but so this is an extra explanation thing. So essentially I have a pyro simulation here. And then when you go in your geometry spreadsheet, so we have all of our primitives here. So density, fuel, heat, temperature, like we've already discussed these things, right? But so to the person asking that question, it wasn't clear, like how are these primitives? Because how does that work? Well, essentially what you can sort of compare this to is, let's say you have a Photoshop layer. Like you have a Photoshop document, and then you have layers. And remember, voxels are sort of 3D pixels, right? So they have X, Y, and Z positions. So imagine that this density, for example, is a layer inside my Photoshop document. And then inside that Photoshop document, like in that layer, is the information of our density. So we can visualize it with a volume slice, which will create a 2D slice of our volume. So for example, if I highlight here my volume slice, I put it to density, and I put it to grayscale. And so now we can preview this on our grid sort of as a value. So let's imagine that now this thing is our Photoshop document. And this is, and then every thing here is a pixel in our document. So when you volume sample something, essentially what you just tell Houdini is open the layer density, and then we're gonna sample something from the pixels. So I'm gonna sample the intensity, like the density of this pixel or the density of this pixel. Now we can visualize all layers. So if I volume sample another layer like heat, so this is our heat layer. You can see heat is essentially the heat, we can use that for coloring later. So that's when you're gonna look inside this thing, or temperature maybe. So then it opens this layer. So it's similar to, like, because with voxels, you don't have, you cannot see like when you're working with points, you cannot really see the voxel information inside here. But with a volume sample, essentially is just asking, yo, open this layer, and then I'm gonna access whichever data is on the thing. And again, we can already visualize that stuff in other ways, like we showed, but I thought it would be useful to sort of show this this way. And again, you get a visualization, and then you get these attributes on a grid. So that's essentially what it also would be like if you were to do it in Photoshop. So I hope that sort of clears it up if it wasn't clear already. But anyway, let's continue with the regular lesson. So let's say there's a point here, and then this voxel looks around and is like, hey, point. And then that point will have a point number. So then this handle will know this point number. And this is going to do it for every voxel and every point. And then I can ask with this handle, like, what do I want to extract from that point? I'm going to do point cloud filter. So with a point cloud filter, you filter out what you want to know. So what do I want to know? Do I want to know your favorite cheese? No, in this case, not. Maybe some other time. But right now, I want to know your density. Let's plug it in into density, because that's what we're doing now. Boop. And we can see we get some nice thing. And what we want to do is maybe promote our radius and our max points, because I want to show you some stuff. Right. So you can see we get our volume. You might see that it sort of looks a little bit soft, right? And we don't quite get the detail over there we want. Well, maybe what we want to do is we want to increase the search radius, because maybe these voxels aren't looking far enough. So we need to increase the radius. So you can see if we increase the radius, it will start finding more stuff. So if we decrease it, you can see it doesn't find anything. If we increase it enough, you can see it finds these details. But it's looking a little bit soft, right? If we compare it to this one. So why is that? Well, what it's doing is it's looking for 10 of its friends. So every voxel is looking around and it finds, oh, it can find 10 friends, and then it's going to ask for their favorite cheese, and some will add and will say brie, and some will say gouda, and some will say whatever, and then it's going to average it out. So it's going to be soft, right? So if we do that for the density, like some will find 1, some will find 0, and then in the end it averages it out, and then we get a super soft thing. So it needs to add less of its friend. It only needs to ask the one that's closest to it. So if we put this to 1, if we put it 0, it doesn't find anything. Put it to 1, you can see we get a much sharper result. So now you can see it looks very similar to what we had there. So you can, if we put it up, it will start sort of be slower. It's not slow, a lot softer. Also slow, by the way. But so let's just put it to 1. Okay, so now essentially we have the same thing, we just took more work. But let's have a look at these. So this one has a resolution of 98 by 73 by 99. So this is super low resolution. If we look at this one, this has a lower resolution. So, but why is this good? Well, in this case, if we look at our original volume here, this has a resolution, our density of 86, 62, 89. So this is, well, apart from the 1 voxel difference that we already had, this is basically the same resolution. Okay, so now this is actually better than this. And that's also what's going to explain the better result we're going to get once we start doing higher resolutions. So I need to do some more explaining. So let's do that. Okay, so have you ever, for example, worked on a 1440p screen and then had a 1080p input, for example, on the monitor? It's going to look a little bit blurry, right? So essentially, that's also what's happening here. So this has a input of a certain resolution, and then it's upscaling it to this new resolution. So it's going to look a little bit blurry because it doesn't correspond one-on-one to this resolution. If I give the monitor example again, if you have 1080p, so 1920 by 1080 on a 4K monitor, so 3840 by 2160, and if you upscale it one-on-one with these pixels, then it's going to look pretty good because it's like every pixel will just be 4 pixels on the big screen. But if you have a 1440p image and you scale it up to 4K, it's not going to match. It's going to be like it doesn't fit exactly in a new pixel count. So then it's going to need to do some interpolation, and it's just going to not be super sharp. And that's kind of what's happening here. So this gets a higher resolution from this volume, from the base volume. And what we kind of want to do is we want to make sure that we keep it as close as possible to the original thing. So over here, we don't see a lot of difference. But trust me, on high resolutions, this does get a little bit better results. That's just what I noticed. Maybe you can try it out. Maybe let's do a slightly higher resolution simulation, see if we can simulation and see if we can actually see a difference. So that's also going to be nicer anyway when we start doing the temperature stuff. You know what? Let's first, before we do the higher resolution stuff, let's keep it at a low res. Let's do the other fields first. So we have so the temperature and the velocity and stuff like that, and then do the high resolution, because else it's just going to be slower to work within this volume.